In a single-factor credit VaR model, default risk is driven by a common market factor, denoted by M, along with firm-specific risk. The key idea is that a firm's asset return depends on how strongly it is correlated with the market, which is measured by beta. The conditional probability of default is given by the formula P M equals phi k minus beta m square root 1 minus beta squared. This means that the probability of default depends on the realized market return. Instead of directly simulating losses, we link the loss level to the market factor using this relationship. To find the market factor corresponding to a given probability, we invert the formula. Phi x equals k minus beta m square root 1 minus beta squared. Since the market factor follows a standard normal distribution, we can map confidence levels to z values. For example, at the 99% confidence level, the z value is minus 2.33. Now let's look at an example. Suppose the correlation beta is 0.25. And we want to find the market return corresponding to a 1% default probability. We start with minus 2.33 equals k minus 0.25 meters, square root, 1 minus 0.25 to the power of 2, solving step by step, square root, 1 minus 0.25 to the power of 2, becomes approximately 0.9682. So the market return M is approximately minus 0.296. This means that the probability of default is the same as the probability that the market return is less than or equal to minus 0.296. In summary, the default probability determines the expected level of losses, while the correlation beta determines how strongly defaults move together. A higher beta means more defaults occur during market downturns, leading to higher credit VaR.